Welcome back, guys. My name is Austin from awfulmedia.com, and this is part 5 of the Making a Simple Game in Unity tutorial series. In this part, we're going to be looking at creating these spikes that I have in the level now. We'll be doing the model in Blender, and then we'll be doing the animation in Unity. We could animate it in Blender as well, but then we wouldn't be able to work in the Unity animator, and that animator is more important to us as this is a Unity series. So the idea with these spikes is to be able to add some pacing to a level, maybe as they are on a timer. You can set the timer. Right now they're on 3 seconds. So after they reset back to not moving, 3 seconds later they'll come back out. At least 3 seconds later the animation will start again. Now these take up space, as we can see, right? They come off the wall, and that kind of messes with our 1 unit hallway here, because then we couldn't fit down the hallway without running into the side of the base for these spikes, and that's not good. So what we want to do, I guess, I don't really know. I don't know what we would do about that. So I'm guessing what we can do, at least for now, is just lower the size of our player. I'm scaling down to about like 0.75. So take a quarter off of him, quarter cubed, and then we should be able to fit by them. Maybe not. If not, we'll lower the size a bit more. But this is just for fun, right? So it doesn't really matter how it comes out in the end, as long as we learn a lot of stuff on the way. We have to fix a few things from previous videos. The first thing is kind of important, and we're going to go to our scripts folder. Notice I have a trap class here. I will delete that for now, and we'll make that again, but we can delete that. We'll delete the spike. In my objects folder, I'll delete the animations folder and then the wall spike itself, and that materials folder inside of the objects folder. Not that materials folder, but our object created the materials folder when we saved it there, which we will do here in a second. But I deleted those so we can create them from scratch. But I want to go to my player movement class. Now in this class, what we have here is we have the update method. Now this is called every frame, so it's based on frame rate, right? But inside of this, we're doing something with physics, right? We're calculating physics, and it's best to do that with a fixed time step. If you are working with physics and you do it based on frame rates, and somebody has 600 frames, say your game's completely unlocked, and can go as high as the computer can run, right? Then you're most likely going to get some funky issues with your physics. And the best way to fix that is to do all of your physics calculations within fixed update. Now that occurs a lot less. It occurs at a fixed time step, somewhere around 50 frames per second, or 50 times per second, and that's what we want. So that'll fix that issue for us. There's one thing down here that we didn't talk about too much. Now, the rotations in Unity are handled with quaternions. We're not going to talk about those, as that's not something for a beginner tutorial. But what I'm going through the quaternion class and accessing the Euler method and then passing some values to it, right? And all I'm doing here is I'm saying on the x-axis I want to rotate these things that I'm instantiating, which are the death particles, to the 270 degree mark. And if you look in Unity, that just refers to, if I select my player, just refers to the X, Y, and Z. So the X of the particles are rotated to 270 degrees, as is our player on the Y. That's just because we rotated them around because we designed our level backwards. And one more thing that we have to do is our game manager is attached to our camera. That was kind of just a temporary thing. So let's go ahead and fix that. I want to create an empty game object. I want to call this game manager. And then I will attach the main camera, or the game manager class from that. I'll just copy that, go here, and I'll paste it within this new one. And then on our game manager class on the camera, we can delete that. Now, inside of this game manager class, we have to do one thing to make sure that this game object doesn't get destroyed in between levels. So if we go from level 1 to level 2, it loads a whole new scene, which means the last scene is destroyed and a new scene is loaded. So when that happens, this game manager would go away, but we don't want that. So on start, I'll do a void start, and I'll say don't. I believe it's don't. My autocomplete's not working. I don't Don't destroy on load, I believe it is. Looking for the autocomplete though. And then we want to say what we want to set to not destroy on load is the game object we're currently attached to, and game object grabs that reference for us. Just pass game object. Now that should be right. I don't know why it's not auto-completing though. That's right. That's interesting. I don't know. I'll have to fix that before we continue though. I'd like to have some autocomplete. If I close want to develop. That's interesting. Why did it... Now do you autocomplete? Yeah, now it autocompletes. I don't know why. I just restarted monodevelop and everything's fine, so I'll just do that again. And that should be all the fixes we have to do for now. There'll be more in the future, I'm sure. But for now, that's it. So what we want to do is go ahead and get started working on our traps. So I'm going to do that in Blender. Blender is a free modeling program you can download at blender.org. And it's pretty powerful. I mean, if you're working in the industry, you may not be working in Blender. If you're working in some kind of visual graphics industry or maybe even gaming industry, I don't know. You may not be working in Blender if you're working for a company. So I'm working in Max. Max is very popular, 3ds Max, very popular in for game design, game development, and game art. Maya is very popular as well, but it's more towards, I'm assuming, movie, cinematics, stuff like that. But Blender is great for the indie development scene because it is free. So when you launch it for the first time, this is probably what you'll see. I'm pretty sure this is default. And what we want to do is make our spikes inside of this. So the first thing I have to do is, the one thing we need to make sure of is Unity and Blender communicates well, right? Need to make sure that the dimensions and everything, when I transfer it over from Blender into Unity, make sure they match. So Unity uses 1 unit equals 1 meter. Blender uses 1 unit equals 1 meter, which is great. So that's the same. No work needed there. But cubes, default cubes in Blender, which we'll be using, and default cubes in Unity, as we are also using, are different sizes. A cube in Blender is 2 meters cubed, and a cube in Unity is 1 meter cubed. So we have to compensate for that just a bit. So inside of Blender, I want to hit N. Now, if you've not worked in Blender, this software it's not user friendly for new people. It gets a bit overwhelming at first. You have a lot of shortcuts to remember because Windows, they're not big on the windows, they're not big on the menus. And say I want to open up a different panel, I would assume the way to do that would be go to Window and then find the panel I'm looking for. No, not how you do that. There actually is an add context to me. That's helpful, I guess. But we have, when I hit N, I bring up the panel that we need, which is the transform panel over here. And I need to access these. Notice the scale is 1, 1, 1. That means it's going to transfer over to Unity for us pretty well. Don't modify the scale directly if you don't have to, but we will be modifying it, and then we'll be applying the scale to make sure that what we applied to it is going to equal out to 1, 1, 1 when we transfer it over to Unity. That'll make more sense here in a second. But the dimensions on the Z, so this is going to be 0.500. That'll flatten it out for us. That's the size I used before, so might as well use it again. Now, before I had these 4 squares cut out in the top. The way I did that was on this, I would just subdivide it by 4. And I want to hit Tab, and that's going to switch my mode, my object mode, to edit mode. Hit Tab again, I'll go back to object mode. In object mode, you're working with objects, right? In edit mode, you're working more with geometry itself. So you see it highlights the vertices here, and you can see the individual edges and polygons or faces. And what I can do is I can come down here to these little 3 buttons right here. That's a vertice selection, edge selection, and face selection, which selects the polygons. So I want to select the polygon selector, and I'm going to right click on the top there. You right click to select things like that. A left click just places this 3D cursor around, which is another thing that's a bit weird for new people, and it's a bit weird for me. I've not used Blender all that much, so sometimes I still click with that, and I'm like, what is that? But you have to right click to select things. You can left click to select gizmos, and that'll do what you would expect. So I want to select the top, then I'm going to hit W. Again, this is a shortcut to get to this menu. This menu is available over here though, as you can subdivide from the add menu here, and just click subdivide, and that would do the same thing. But I'm gonna hit W and go to subdivide, and that subdivides that one face into 4 faces. Then we can work with that. Holding shift and right click these individual faces. Now I want to inset these. If I was to just bring these down now, it just lowers the whole cube. That's what it should do. As that is a single face now, we have it selected. We're moving all 4 faces together. What I want to do though, hit I, and that will inset the faces. But this insets it based on all of the object or all the faces together. We want to inset them relatively. So now it does this. And that's not going to work for us. Hit I again, and then it will do this, right? And I want to go about right there, and that looks pretty good for me. So hitting I again will do it relatively for each face that is selected instead of all the faces together. Now I want to right click in these new faces that we created and grab them just like that. Now these have to go down. But if I just bring them down now, it'll bring all of them with it. Well, okay, so I somehow managed to turn on proportional editing, and that's not what we want. What that's going to do is, notice now they move down individually, but with that on, they would be moving down the faces connected to it proportionally in a way. Don't really know whatever, not what we're here for. I want to do it now though where I can just bring the faces down without actually bringing these edges down with it. The way we can do that is I can inset again, and doing that and just hitting enter. Now what that will do is it will inset it, but it won't move the edges in further than they were. So now I can just bring these faces down, and it will just be just like we want. Okay, that's the result we want. I can't promise the way we achieve that result is the proper way of doing it, but again, I am not an artist. I just do this kind of stuff quickly for my own development art, and it's not the prettiest stuff, but it works. And that's all we want. So we hit tab again to come out of edit mode, and that's what we want that to look like. Now we need to create the spikes. I want to create a single spike, and then we'll duplicate them and do a little bit of math to position them inside the center of these cubes. So make sure that's centered in the world 0, 0, 0 as it is. So I want to go to add, and go to mesh, then go to cone. Now we're going to use the cone to create that spike. But that doesn't look like a spike, does it? Well, kind of maybe, but not the kind of spike we want. So I want to go down here to the bottom left of this panel on the left side of the scene here, and notice the vertices filled. Now I can drag this down and get rid of most of the faces. We don't need that many. We just want that. That's what we want. And notice it's rotated a bit. So we can rotate this, Z, 45 degrees, and that'll give us the rotation that we want. Now I can just move it into place here, and then we'll scale it based on, we'll just eyeball it, I guess. And we want the Z will be about 1.5. This will be about 0.5 and 0.5. Does that look okay? That looks, is that, I don't remember what the other one was like, to be honest. We'll just work with that. That'll work. That works for me. But now, this is centered in the world. This cube here is centered in the world. Now what I want to do is I want to center this in each quarter of this cube. And the way I can do that is pretty simple. So it's 0, and this is, we know it's 2 meters this way, 2 meters this way. So I'm going to put 0.5 here and then 0.5 there. And that will center it from here to here and from here to there. So centering it as a result from the center to the corner. And we can do the same for each of our different little spikes here. So I'm going to hit Control C, then click yeah, then hit Control V, and click yeah, and then move that over there and do the same thing with the positions. Let's put this negative 0.5 and then 0.5. Now I can hit Control C, yeah, Control V, yeah, and then bring this down with it selected there, and right click that, make this negative 0.5 and then negative 0.5. Hit Control C, Control V, move that over there, right click that, put this at 0.5 and then negative 0.5. And that is what it looks like. I'm gonna hit A to deselect everything. Oops, Hit A to deselect everything. And that's what we have. Is that like the other one? Doesn't look like the other one. Who knows? Maybe it is, maybe it isn't. These cones here, these spikes, have to be separate objects for us to be able to animate them separately in Unity. Now we could animate them in here, as this does offer some pretty awesome animation features, but Unity is where we're working in, so we will be doing this in Unity. Now what I want to do is I want to hold Shift and click each of these spikes. Then I want to hit, I believe it's J or Control J, and that Control J will join them to a single object, and that's what we want. So I can select one of them and it will select all of them. And now our bottom is completely separate, which is what we want. So we can take these and move them up and down, and that's how we're going to animate them. And that is the spike. The spike is done. Now I'm going to go to File and go to, we're going to Save As, and I want to save this Blender file. I'm not going to export it to an object file or an FBX. I'm going to save this file into the Assets folder for our project. That way, whenever we make a change in Blender to our file or to our model, it will change it in Unity for us without us having to go into Unity and update the file, replace it with a new one or whatever. This will do it for us. So to do that, I'm already here, I guess, so that's handy. I'm going to go to my Google Drive folder and go to, just go out to the drive itself and find, what was it called? Go home, and then go to Assets, and then I'm going to go to Objects, and I'm going to save this in here as Wall Spike. Then I'm going to click Save as Blender File, and that is now in Unity for us to look at. Open up Unity, little progress bar will pop up telling us it's doing something, then go to the Objects folder, and there it is. It's pretty, right? Couple things we have to change. We're going to be not importing an animation. There's no animation in the object file for it to look for. So I'm going to uncheck that and click Apply. That'll get rid of a few things in here for us. One more thing is this avatar. This is not going to be requiring a rig of any kind, a bone structure of any kind. So under Animation Type, I'm going to go to None and click Apply. And that's that. Got rid of the avatar for us. Now on the model, if I was to drag this out into the world, we see that since our cube in Blender is 2 meters cubed, right? Then this is actually going to be two times the size of our cubes in Unity, and that's not good. So what we can do is under Meshes and on the Scale Factor field, I can scale this to a factor of 0.5, and that's what we want. But notice also, it's trying to shade this for us, which is really nice. It's doing a really good job, but we don't want it to shade it for us. We don't want it to do any of that. We want to match our cubes in the world, which have this hard shading going on, and that's what we want it to do. So under Normals and Tangents, I'm going to go to Normals, and I want to change it from Import, as there's nothing to import. I don't want it to look at the Blender file for it. I just want Unity to calculate the normals for us. That way, it will pretty much look like the rest of the world. Turn the smoothing angle down. It wouldn't do anything where it's at anyway, but I want to turn it down just because there's no reason to have that, as there will be no smoothing for the shading. Click Apply, and you'll see that not only did the scale change, but the shading on it changed as well. So now it matches the look of the environment, and that's really important. I'm sure what that with the preview there. Oh, we didn't apply. Let's go back into here, and I'm going to hit Control A. It's going to bring up this little Apply Context menu. Now I want to apply the rotation and scale, and thankfully there's just a single rotation and scale option, and that will apply the rotation that we rotated the spike around. Remember, it was angled, and then we scaled it a bit. So now notice the scale is 1, 1, 1, and the rotation is 0, 0, 0. But our dimensions remain the same, and that's very important for our scene. Now I'm going to do the same thing with the base. Make sure this is 0.5. I'm not sure what that was, but it needs to be 0.5. And then I'm going to do the same thing in Control A and say rotation and scale. We didn't rotate it any, but that's fine. Let's do that anyway. Now hit Control S, and I want to save over the assets objects wallspike.blend, and that will update it in Unity for us. So there shouldn't be anything crazy going on. Notice here are all the items, and that's exactly what we want. And now notice the preview looks as it should. The preview was a bit screwed up last time, and now it looks fine. So now we have to create an animation. Now, for this game, the spikes are going to work with a collider attached to the spike itself. Notice in the object we have the cone 002 and then the cube. I want to name this to base, and then this to spike. Now the base has nothing. Nothing's going to be going on with the base. It will have a collider, so we can't walk through it. But the spike is where the logic's going to be, and the spike is where the collider that hits the player is going to be, and also the animation will be taking place on the spike itself, all within the wall spike parent here. Now I want to name this just to wall spike's fine. So what we can do is start the animation, but I want to go ahead and rotate it around because it will never be on the ground like this anyway, so no reason to have it like that, as you couldn't really walk over it if it were on the ground as it is. I want to grab the wall spike parent, and I'm going to rotate this on the Z for now, 90 degrees. Or we could do -90, so we don't have to rotate it around the other way. Just do -90. And then I want to hold down V on the wall spike mesh here. Holding down V, select that vertex in the back there, vertex in the back there, and just drag it over to snap it to that cube. And now we have our spike on the wall. And the way we're going to animate this is the spike is going to start inside of the wall. And you can't see it because it's inside of the wall. And there will never be a spike without a wall. So this is great for us. Very simple to do. And now what I want to do is I want to go to Add Component. And I'm going to add the animation component. Okay? Now when I add this, not the animator component, by the way, the animation component. Animator's for something different, and we may get into that actually. But for now, we're working with the animation component. Now this is looking for an animation clip, and it has a couple of options for us. Now this can take an array of animations, and that's awesome, and we won't be using that though, because our little animation will just be a single animation for our spikes. So let's go ahead and start the animation. On the spike here, I'm going to go to Project, I'm going to go to my objects, right click, and create a folder. I'm going to call this Animations, just ANIMS. Inside of this, I'm going to go Create, and I'm going to create a new animation, not animation controller, another different thing, and call this Wall Spike. Now, how do I edit this? I'm just going to go to my window and go to Animation, okay? So what I'm going to do is select the spike now, and I'm going to just click Add Curve. And now since I made this animation before, I can just double click on that and say, yeah, that's what I want to save this to. And now what I can do is tell it what I'm going to animate. I'm going to be animating using the transform component because all we're going to be doing is moving it on the position. So I'm going to click the plus sign there, and it adds that to our animation window. And now if you're familiar with animation programs, these will look like just keyframes to you. If you're not, I'm not really going to go over animation in this part, but I will show you how to animate very, very basically in the Unity animation window. So if I was to click play, we'll see that nothing happens, right? It goes from this keyframe to this keyframe with no change in the middle. But the starting keyframe and the ending keyframe, which on the X and Y and Z all have individual keyframes, but we can change these all at the same time, which is great. So it starts and ends in the same location, but somewhere in the middle, I want to just bring this spike out. So I'm just going to grab this gizmo on the spike, drag him out to about right there. And notice when I do that, it automatically adds these keyframes, and that is super cool. So now I have the information for where my position is going to be in the animation window. Now if I click play, look at that. Already our spikes are moving. So easy to do. Now I'm just going to click this top keyframe and drag all of these back to about right there. Click play, Now that'll shoot them out a bit quicker. And I want to make sure if I was to go on this, right click, I want to set this to flat because I want them to just come out without smoothing. Go back in with a bit of smoothing though, that'll be fine. And that's exactly what we want. That looks really good. And don't worry about, I do think our spikes are shorter this time. I do believe they are. That may be fine. Notice how it's looping over and over and over. That's just because we're going through the timeline here and it gets to the end and repeats. We'll be controlling when it plays and when it stops and stuff from a trap class. But now that we have this clip, if I was to click play, it doesn't have anything there for us, but I can drag this spike and we can see it not playing it correctly. That's awesome. Not playing correctly at all. That's fine though. If I was to go back to the spike, I want to drag this clip and drop it onto the animation field for the animation component. Now, if I click play automatically, if I was to click play, make sure we go here, click play, it should just play the thing, right? And it does. It plays it and goes away, and that's great. But what we want is to be able to control when it plays it, set it on a timer of some kind, and then when it comes out, detect a collision. So on the spike, we have the spike component there. I want to go add component, and I want to add we'll add a box collider. So let's bring this out just so we can see the box collider, and it adds it exactly how you would want it to, all around all four of those, as it is a single object, and that's really good. So we have to now, I'll just make that go back in there. We can just check to see when we hit that, but I want to make sure this is a trigger. I don't want it to hit us and send us through a wall or something if it was physics based. So make sure you can just walk through it, but when you do, you die. It's just a little safety thing. So now I'm going to create a class. I'm going to go to my project folder, go to scripts. I'm going to right click and go create C# script. Done this a few times now. And I'm going to create a trap class. This can be a class we can use for more traps than just one. We can set it up to take multiple types if we wanted to, but for now it'll just be a spike trap class. So the first part is going to be a public float of delay time. So the amount of time in between actions, the amount of time in between that trap coming out and the trap going in, it'll wait the amount of time we set here. Now we're not going to be using update for this, we're going to be using a coroutine, and we have covered that in part 9, I think, the last part of the introduction to C# in Unity. Now if you're not familiar with a coroutine, I would highly suggest you go check that out. Just go ahead and click down on that channel link and go to my videos and watch through that introduction series. Actually, if you don't know a lot of the stuff we're talking about, it might help you out quite a bit. But we're going to set up a coroutine, and we know that to do that, it has to have a return type of enumerator, right? And this is going to be called, just something simple for now, go. So everything inside of here, we will call whenever the class trap is instantiated, which would be at the beginning. So we'll do start coroutine now, and then we can just call go through that method. And now whenever this starts, go will be called, and that's what we want. But now inside of this, we're going to do something we've not done yet, and that is setting up an infinite loop. We're going to be using while, and then detecting while something is true, and while something is true, do something. And if we've done that before, well, not we, but I've covered this kind of stuff in PHP quite a bit, because PHP uses a while loop, very familiar, or very similar to what we're going to be doing here. So I'm going to be saying while, and then while a condition, so inside of the parameter parentheses there, we can pass a condition. But since we want this to be an infinite loop, something that will never not be true, what's never not true? What's always true? Well, true. True is always true. You can't argue with true being true. So this will always run. There's no reason this should not run. So while this is true, we want to play the animation that is attached to this game object. So the way we can do that is by accessing it through animation. Now this is just a setup reference again for us, kind of like a rigid body or a game object is for other things. For game objects, animation is set up to reference the animation component. Now I can say animation.play. And since this is the default animation on this game object, we don't have to pass it a value or a string name or anything like that. It's just animation.play. And that will play the default animation on this object. And that's what we want. But if I do this now, this will just play over and over and again forever. And it won't even do that actually because we don't have a return. And this is looking for a return because it is not set to void. So we have to have a return. And the way we can do that is when we're saying while true, do this, we'll do a yield. As it is a coroutine, we can yield, which means we can stop it for a single frame or for a few seconds or whatever. So I'm going to say yield return new, and we're going to return new wait 4 seconds. Done this before. Same thing this time. But in here we can pass a value. So I'm just going to for now pass it 3f, which is a 3 float, right? So 3 seconds, this will wait, then it will come back through and do this again, hopefully. So go back out here, check our errors. There are no errors, which is great. If I click play, notice the spikes come out, go back in. 3 seconds later, they should come back out. They did not though. What did that do? Let's go to the animation. Let's turn off play automatically. That's the only reason they came out anyway. Oh, I don't have the trap, the class attached. That would do it. Now let's set the, or just click play. It comes out, go back again. 1, 2, 3, comes back out and goes back in, and then waits 3 seconds, comes back out and goes back in. That was simple, right? And we got something that's pretty cool looking that works. And all we have to do now is check for collisions. When a collision happens, kill your player. And we already have that method set up, so what we have to do is call die. See how easy this gets once you start going with it? So what we can do for ease for our game is, or at least for our production of the game, I can select these spikes and we can add them to a tag that already kills the player, and that would be enemy. But this is a trigger, and our enemy is not a trigger, so they're different. We have to do different detections. But we already have a trigger collision method set up. So all we have to do is copy this method, paste it there, and say enemy, and then just call the die method. So we'll say die when that happens. And now when we touch the spikes, we should die. But one thing pretty interesting here is our base doesn't have a collider on it. So we can just run through the base, and we'll probably die because we'll be touching the cubes anyway, or the spikes anyway. You notice that we just run right into that and die, even when the spikes aren't out. But what if I set in front of it? Boom, it kills me. And that's what we want. So what we can do though is on the base, we may have to play around a bit with this, but I want to add a box collider. Bring that down so I can actually see it in the scene. And just for safety, I'm going to up this on the Z. Just up it a bit like that. Maybe that way I won't run directly into the spikes when they're in the wall. Yeah, there we go. Now just run into the spikes themselves, and it will in fact kill you. So just do that, and we're good. When it comes out, it'll kill you. So if I sit right here, it'll kill me. And the enemy will kill me as well. Don't forget that. Now the enemy's not walking around. That's because before I started, all I did was go to the ogre and uncheck the patrol. That's because I had some spikes here, and I wanted to show you what they look like. So all I did was uncheck his patrol class to make him not patrol around. And that's how that works. So now we can throw these in through a level and stuff. And I can just duplicate this one. What happens if I duplicate it though? Now I want to rotate this parent around, say this way. Right, so I would rotate it around negative 180 degrees. Does it still function correctly? That's a good question, didn't test it. There we go, functions correctly because the parent is what this the spikes are based their positions on, their rotation on, everything is based on the parent, not based on world, right? So that's how parenting works, and that is working great for us. So now we can take this one, holding V down, grab right here, and just snap it. Well, it's being a bit, I don't know where it went. Grab that, bring it up. I'm going to rotate it back around this way. So that would be 0. Why is the X rotated? I have no idea. I'm going to hold V down. holding V. There we go, I couldn't see it. And just place one right there. And now we have to see if we can actually fit by that. If not, our player's too big, and we'll lower the size of our player. So I want to squeeze through here. Yeah, you can, but it's a bit tight. Notice in this view, you can't actually see what's going on at all. And that's not good for a game like this. You have to be able to see what you're doing, or you're not going to be able to play correctly. So I'm just going to bring this camera, not that way. Bring it up a bit, over a bit, and then look down a bit or something. I don't know. Maybe up a bit more. And the cameras can be different for each level depending on different setups. It doesn't really matter. It's up to you when you're designing the game. But now we can kind of see how to squeeze by here. I want to scoot up here, go for that spike, squeeze by. I don't like how he hit the spike though. I mean, it's the perfect size because that's 1/4 of a meter and this is 3/4 of a meter. So you can understand how that could be so tight, right? That's the math that we did. But I want to do 0.6, something a bit odd. But that will allow us 0.15 of a meter to get through there, which is all we'll need to just go right by. From in between the spike and the wall, though, when it comes out, it will kill me and I will die. Make sure we don't have anything bad going on. We don't. Cool. And that is how that's going to work for us. We may add another trap or two in the future, but next time, what I want to do is actually work on a scoring system, a timer of some kind. I was thinking we could do a timer that starts at 0 and goes up, and the longer you take, the less your score. Maybe we could do something like each level has a par. You have to beat this par in order to get 3 stars. If you meet the next level of a time, you get 2 stars, something like that. And we could add some tokens throughout each world that you have to get to that would kind of divert you from the direct path, but give you some kind of bonus of some kind. You know, little gamey things that games have, you know, that would be cool. But that's for a different time. Next time, we will come up with some kind of scoring system and work on that. That's it for me though, guys. Thank you for watching. I am sorry I didn't get one out yesterday. I did record one, actually, but the drive I was saving it to, that I was saving the recording to, was full, and it doesn't tell you that, apparently. It just waits until you finish recording, and then there's no video file waiting for you when you go to look.